Imagine the universe as a very delicate game of balance. If you've ever tried to balance a stone on top of another, you know that you have to be very precise not to let it fall. The universe is like that, but on an infinitely larger scale. When the universe began shortly after the Big Bang, it expanded very quickly. But this expansion had to be just right. If the universe expanded too quickly or too slowly, nothing we know today would exist. Stars, planets, and even ourselves depend on this perfect balance. There are two main things in this balance. 1. Expansion rate. This is how fast the universe expanded after the Big Bang. 2. Amount of matter and energy. This is everything that exists in the universe, from stars to light. If there was too much matter and energy for the expansion rate, the universe could have collapsed back in on itself. On the other hand, if there was too little matter and energy, the universe would expand so fast that stars and planets would never form. So far, it seems that the universe has got this balance right, which is incredibly unlikely considering all the possibilities. Scientists wonder why the universe has this perfect balance. One theory is cosmic inflation, which suggests that shortly after the Big Bang, the universe underwent an extremely rapid expansion that helped establish this balance. This means that it expanded a lot, but a lot in an incredibly short time. And the interesting thing is that while this was happening, it wasn't matter, such as stars or planets, that was moving. The space between the particles itself was growing. Imagine if space itself was being stretched. And to understand the universe, we need to know the 4 fundamental forces that control everything. Gravitational force, the force that attracts objects with mass to each other. Electromagnetic force, the force that acts between charged particles. Strong nuclear force, the force that holds together the particles in the nucleus of atoms. Weak nuclear force, the force involved in certain types of radioactive decay. In the beginning, these forces were all the same, and it was not possible to distinguish one from the other. These forces play crucial roles in the formation of the universe as we know it. The idea that all of this, from the expansion of the universe to the fundamental forces, fitted together so perfectly to allow life and everything else is truly fascinating and a great mystery to science. As the universe cooled, because it was expanding, these forces began to differentiate. They began to behave in different ways, each following its own set of rules, allowing matter to form and eventually give rise to everything we know: galaxies, stars, planets, and, of course, life on Earth. As we explore areas such as quantum gravitation, dark matter, and dark energy, it becomes clear that although these fields may seem far apart, they all share an extraordinary common ground. But what if I told you that this common ground leads us to an even more surprising revelation? That the universe seems strangely adjusted to the existence of life. Imagine for a moment how lucky we are to live on Earth, a planet that is neither too big nor too small, orbiting at the perfect distance from its star to sustain life. That's rare enough. But there's something even more fascinating. The very physical laws of the universe seem to be meticulously calibrated to allow life to flourish. Now, a skeptic could argue that this is simply because physics was formulated by human beings. However, I'm not just talking about the equations, I'm talking about the fundamental properties of the universe. Imagine that the universe has some fixed rules, like a game that always follows the same instructions, no matter how many times you play. In science, these rules are called constants because they don't change. One of these rules is the speed of light. No matter where you are or how you move, light always travels at the same incredibly fast speed. This is special because it shows that light follows its own constant rule, which we discovered thanks to equations created by a scientist called Maxwell. Another famous rule is Einstein's equation EMC2. This rule tells us something surprising. Matter, things that have mass, like you and me, and energy, like light or heat, can transform into each other. This idea also depends on the speed of light being a constant, showing how these rules are interconnected. There are other important constants that help scientists understand how the universe works, such as the charge and mass of very small particles, which are essential for quantum physics, the study of very, very small things, and electromagnetism, the study of how magnets and electricity work. There's also Planck's constant, which is crucial to understanding how light and energy behave at very small levels, and Newton's gravitational constant, which helps us understand gravity, from why your cell phone falls to how to calculate the mass of a black hole. These rules, or constants, are always present in nature. When scientists measure them, they always find the same values. It's interesting how we accept these constants without much question, because they form the basis of how we understand the universe. Imagine you have a beach full of grains of sand. If you try to pick out a single grain of sand from that beach, without looking, your chances are very, very slim, because there are so many grains of sand. Now imagine that it's not just one beach, but the beaches of 10,000 Earth planets combined. If you tried to pick out a specific grain of sand from this huge amount, your chances would be so minuscule that it's almost as if it were impossible. The main point here is to compare this tiny chance with the probability that all the rules of the universe, such as constants like the speed of light, the charge of the electron, among others, have exactly the values they do. These values allow the universe to exist as we know it and for life to develop. It's as if in the midst of so many possibilities, so many grains of sand, the universe had chosen exactly the right values so that we could exist. Stephen Hawking talked about this in his book, A Brief History of Time. He said that the fundamental numbers of the universe, such as the charge of the electron and the ratio between the masses of the proton and the electron, seem to have been adjusted very precisely to make life possible. This is like saying that somehow the universe was tailor-made for us. In other words, the chances of everything being the way it is and us being able to exist are incredibly small. But here we are. Some defend the multiverse theory, suggesting that there are infinite universes, each with its own physical constants. In this scenario, it's not so surprising that there is at least one universe, ours, where the conditions are perfect for life. Others, like Hawking, have proposed that quantum mechanics and the superposition of states could explain these apparent coincidences. When we talk about life and how it exists, some people imagine that life has to be similar to what we know here on Earth, with water, oxygen, etc. But this can be a very limited view, because we are assuming that life can only exist as we know it. This is a bit like thinking that all dishes of food should taste the same as our favorites. It doesn't take into account the incredible variety of flavors that exist. The question, what is life, is hotly debated and has no simple answer. Even on Earth, defining life is complicated because there are so many different forms of it. Now, imagine trying to define life for the entire universe, where conditions can be totally different from those on Earth. This makes us question whether it makes sense to talk about fine-tuning the universe for life, the idea that the conditions of the universe have been perfectly adjusted to allow life, or whether life as we know it is just a result of chance among many possibilities. If there really was a fine-tuning for life to exist, this raises other questions. How does life affect the universe? Why does most of the universe seem uninhabitable to us? And if life is so important, why don't we see it more often throughout the universe? If we believe that everything was tailor-made for our existence, we must also ask ourselves, what is our place in the cosmos? After all, most of the universe is uninhabitable and mysterious. The beauty of this lies in accumulating knowledge and at the same time, recognizing how little we know, keeping our curiosity alive to continue exploring. I'm Paul Edward, and I'll see you in the next video.